All right. So these are the forces, right? So this is written, by the way, let me just say this is wrong. Okay, it should be IL cross B. So you need to write the IL first in that, right? Because it's really a vector cross product. Right? It's IL cross B, which is ILB sine theta. Okay. Now this is really a scalar formula, so it doesn't matter that you write it that way. It's just a principle. Why would they write it this way when they could write it this way? And not confuse kids later. Okay. Anyway, this formula is for a magnetic field. So if you have, say, a magnetic field like this, and you have a wire that's in the magnetic field for some length L. The L is the overlap of the wire and the field. The force will be the magnetic field times the current that's flowing in the wire times that length times the sine of the angle between the magnetic field between B and I. Okay, so in this case, the magnetic field is out of the page, right? And this is in the page, and so this is 90 degrees. Sine of 90 is 1. Okay, so we're all set for that, right? That usually they're 90 degrees, and we don't worry about that. But if they're ever not 90 degrees, like if you've got magnetic field like this, right, and then you've got a thing that's like that. Here's our current. Then this is what you do. You play some tail to tail and use that angle like that. Okay, that would be your theta. This would be your B. Yeah, there we go. And the same is true for the angles for this guy. Just remember for this one, okay, just remember the electron is the other way. Okay, so this is your charge, right? So that's either plus the electron charge, that is, it's a proton or something like that, or any positively charged thing, right? Okay, could be a positron too, right? Okay, this is our velocity, or it could be negative E, right? It could be an electron or a tau or a muon or something like that, right? Okay, but just remember that the minus sign that's on the charge makes the force be the opposite direction, right? Because all of these things are both in the right-hand direction. Right, and then this is our velocity. And then this is our, this is the sine of the angle, and it's the same angle that we talked about there. Okay, this thing is almost always, you almost always see this thing causing circular motion. So QVB creates centripetal force, right? So you'll find this is, I actually have that in there. Let me find that. That one is mv squared over r. There it is. It's 613. That formula. They actually have that formula. It's section 6.1, formula 3. They've got that. So anyway, and then you can solve for radius of curvature, et cetera, et cetera.